Today I want us to look at the differential, how to differentiate the differential equation using the D inverse operator. And to start, we have to know how to express the differential equation in terms of the D operator. And one should know that the first derivative is represented by D, the second derivative is represented by D squared, and the third derivative is represented by D cubed, up to, if we end up having the up to nth derivative, it will be represented by dn. And we have here a question that I want us to go through and see how we are going to solve the steps we are going to use. The question is that we want to solve the d square y over dx square plus 2 dy dx plus y is equal to sine of x cos of x. So the first thing is we need to express the equation in terms of the d operator. As I have said, that the d square is represented by, but the second derivative is represented by d square, first derivative is represented by d, and the first derivative is represented by the first derivative is represented by d. So from here, so we have the d square plus 2d plus 1. If I factor out y is equal to sine of x cos of x. Now to find the complementary solution, we need to find the complementary solution at a particular solution. So we start by finding the complementary solution. The complementary solution will equal the first equation to 0. Equating the equation 1 to 0, we have the d square. We have the d square plus 2d plus 1 into y is equal to 0. Now we take the auxiliary equations. The auxiliary equation, what is this one, what is inside the bracket? D square plus 2d plus 1 is equal to 0. This is a quadratic equation in terms of the d, and therefore you can either solve it using the quadratic formula or by looking at the factors of the equation. Now for that, we have the d plus 1 square, or rather d plus 1 into d plus 1 is equal to 0, giving us the roots as d1 is equal to d2, which is equal to -1, and therefore the roots are real and equal. Having got the equal and real roots, then we have to express the complementary solution. We will express the complementary solution, which is represented by y set c of x as c1 of x plus c2. This is normally exponential alpha x, but our alpha is the root. So our alpha is -1, so then it becomes -x. Now the next thing is to find out the particular solution. The particular solution, now we go back to equation 1 and make y the subject. Making y the subject, we will divide both sides by d square plus 2d plus 1. We will have now y p of x equals to 1 over d square plus 2d plus 1 sine of x cos of x. But since you have here the product of two trigonometric functions, then we'll have to know some identities. However, sine of a plus b is equal to sine a cos b plus sine b cos a, and if we are subtracting, it will be sine of a plus sine of a cos of b minus sine of b cos of a. So look at when you add the two identities, we have sine of a plus b plus sine of a minus b is equals to 2 sine a cos b. If we compare the equation, and if we divide by 2, then we compare with now this one, then our sine x, it will be like sine a, and cos 2x will be like cos b, and this one will be over 2. So if you compare and then write this one, then it will be sine x cos 2x will be a half into sine of x plus 2x plus sine of x minus 2x. If you work out inside what is here in bracket, have a half of sine of 3x plus sine of negative x. But sine is an odd function, therefore the negative can move outside there. Then we have a half in the sine of 3x minus sine of x. Therefore, we are going to replace sine x plus 2x with a half sine 3x minus this. Then will be particular solution is equal to 1 over d square plus 2d plus 1 into a half sine 3x minus sine x. Now, if 1 over d square 2d is open to this, the function of the what inside the bracket, then I have 1 over d square plus 2d plus 1 into a half sine 3x minus 1 over d square plus 2d plus 1 a half sine 2x. Look, here we have the d square. Now, this one, when you have the trigonometric, this one will be our alpha, and then our alpha here is 3, and our alpha here is 1. So, next step, we are going to replace the d square with negative alpha square. We replace the d square with negative alpha square. Now, replacing the d square, we are going to have replacing the d square, we are going to have the our first negative, the d square, negative 3 square will be negative 9, and then negative 1 square will be negative 1. If we add the negative 9 plus 1, we need to get 1 over 2d minus 8 and a half sine 3x minus 1 over 2d into a half sine x. Now here we are going to take a half outside, and then we are going to remain a 2d plus 8, and then take the conjugate of 2d minus 8, just even 2d minus 8, 2d plus 8 sine of x. Then when we multiply this one, we get 1 over 4. Then when d move up, we get the d inverse of sine of x. The d inverse here will mean the integration. From here, when we multiply the 2d minus 8 into 2d plus 8, we are going to have the 4d square minus 64. 4d square minus 64. When you multiply that, when you open up that, then since you are still having the d square, then our alpha again will be 3. Our alpha will be again 3, and then on the 4d square, we are going to put the d square with negative 9. So it will be 4 times negative 9, giving us negative 36 minus 64. Then sine of 3x. Remember, the d inverse, when you integrate the sine x, will give you negative cos x. Now the negative cos x, negative and negative will cancel, will give us the positive, and then this will remain 2d. Remember, negative 36 minus 64 will give you 100, then multiplied by 2, giving you negative 200. So this one, the 2d plus 8 will open on sine of x, therefore negative 1 over 200 into 2d sine 3x plus 8 sine 3x plus 1 over 4. Now, therefore, the particular solution will be negative 1 over 200. If we differentiate, that was 2d cos 3, 2d sine 3x, then it will be 2, then we differentiate sine 3x, we get 3 cos 3x. So 2 times 3 will give you 6 cos 3x plus 8 sine 3x plus that one. Therefore, to get a general solution, we have now to add the complementary solution plus the particular solution. We will now get this is our complementary solution. Then from here is our particular solution. That's give us the answer. That's the end of our class today. Thank you.